All right, everybody. The first section in the next unit is going to cover graphing systems of equations. So go ahead and pause the video, copy down your lesson title, your standards, and your I can statement. Now, I have given you a set of guided notes. They are 3 pages long, so they should be stagger stacked and taped into your notebook. What I've done is I've taken pictures of the guided notes, and I'm just using those guided notes in this video. So everything should just be able, you should just be able to follow along and basically fill in the blanks, okay? So the first thing we need to talk about is a little bit of vocab. So what exactly is a system of equations? A system of equations is just a set of 2 or more equations, okay? So it's a set of 2 or more equations. All right? And then for the next one, we need to talk about what the solution of a system of equations is, okay? The system or the solution is an ordered pair that solves both equations at the same time, okay? So we are going to be graphing these on an XY axis, and you're looking for the ordered pair that solves both of those equations at the same time. And that's what we call the point of intersection, okay? The point of intersection is the solution to the system. Okay, and that's going to be an ordered pair, remember, an XY ordered pair. All right? So go ahead and copy those down if you haven't already. And then we're going to move on. Now, what we need to do first is we need to be able to identify the point of intersection just from looking at a graph. So what you do is you just basically look for where the lines cross. Okay, so in this example number 1, take a look and your point of intersection is right there. Okay, so that ordered pair is 4, -3. So that is the solution to the system that is graphed on that XY axis, okay? Go ahead and move on to the next one. Take a look at your point of intersection, which is right there. That ordered pair is 8, -3, so that is the solution of that particular system, all right? Now, go ahead and try the next 2. So hopefully on this point of intersection here, you got an ordered pair of 2, -2, and then on number 6 you got a point of intersection of 1, 2. Okay, now remember your x's go first and your y's go second. Okay, now what do you think is going to happen on the next 2 examples? Okay, these are special cases. So take a look at those parallel lines and think about what the solution of the system would be. Remember that we're looking for a point of intersection. Do parallel lines, for number 4, do parallel lines ever intersect or cross? Hopefully you said no. So the solution is none, okay? So parallel lines never intersect. So there are no solutions for parallel lines, okay? Now, take a look at number 3, the last one on that first page, okay? Now, I know you can't really tell it, but this is a system, and it's one line graphed on top of another line. It's the same line, okay? So think about the points of intersections and think about how many points that those lines share. So, hopefully you can picture the fact that if you have the same line, they're going to share all points. So the solution to these are infinitely many, because each and every point on that line is shared by both of those equations. Okay, so that'll make a little bit more sense here in just a second. Go ahead and go to the second page. Okay, now we are on page 2. Okay, so we are going to start graphing systems of equations in order to find the solution. So when finding the solution of a system of equations, you first graph, okay? And then you look for the solution or the point of intersection. So you're going to graph and find the point of intersection. All right? Now think about it. When we graph equations, okay, what form do we like? So in order to graph the systems, both of your equations need to be put in y equals mx plus b. Okay? So go ahead and move down to the example number 1. So you've got y equals negative 1/2 x plus 4, and you've got 3x minus 2y equals 8. Okay, the reason why there's an and there is because this is a system and your solution has to solve both of the equations at the same time. All right, so notice that your first step is to put the equations in slope-intercept form. The first one, of course, is already in slope-intercept form, so you can just copy that one down in the box. Okay. The next one, you're going to have to shuffle it around. So remember that first you're going to have to subtract 3x, and then you're going to have to divide everything by negative 2. So go ahead and do that very quickly. Okay? When you do that, you get y equals 3 over 2x minus 4. All right? So now, okay, what you want to do is go through and you want to identify your slopes and your intercepts in order to be able to graph. So on the green line, my slope is 3 over 2 with a y-intercept of negative 4. And then on my red line, my slope is negative 1/2 and my y-intercept is positive 4. So just based on that information, go ahead and graph those lines. So when you graph those lines, this is what your picture should look like, okay? Now, what you want to do is you want to look for that point of intersection, all right? So notice that our point of intersection is right here. Those lines do cross, and they only cross one time. So because they only cross one time, how many solutions are there? There's only one, okay? Now, where is it located? Well, that first quadrant is where it's located. So just put quadrant 1 here. And then over on the left at the bottom where it says what is the solution, that's where you put the ordered pair of the point of intersection. So it's 4, 2. Okay? So one cross means one solution, and then the ordered pair is the point of intersection. And you're done. All right? All right, so let's move on to the second one. What I want you to do on this one is get as far as you can. So start by putting those equations in slope-intercept form. So when you put those equations in slope-intercept form, this is what you get. On the green equation on the right, don't forget that when you subtract x from both sides, you are going to end up with a negative y right here. Okay, and so you have to go through and divide everything by negative 1, and that's going to change all of your signs. Be careful of that, please. All right, so what I want you to do now is I want you to go ahead and graph both of those on the coordinate grid, and I want you to identify your solution. Okay, so when you graph both of those lines on the same xy axis, this is what you should come up with. Okay, and then the point of intersection is the point where the lines cross. That's right there. And that solution is 2, 0. So there's only one solution here. Okay? Don't worry about what quadrant it's in. It's just one solution. Now, make sure you're covering your graphs by repeating your slopes over and over and over. Okay? This is the section for the reason why I've had you do that all year long, all right? Okay, now let's move on to the next example, okay? The next two, example 3 and example 4, are special cases. One will be parallel and one will be the same line. So go ahead and put those equations in slope-intercept form for example 3 and see if you can answer questions A and B and identify your solution. Okay, so when you solved those equations for y and got them in slope-intercept form, hopefully you got these two equations. Now, just by looking at these lines, okay, hopefully you know that you are looking at your slopes, okay? So take a look at those slopes. Because those slopes are the same and our y-intercepts are different, then hopefully you know that these are parallel lines. All right? So how do you know how many solutions there are without graphing the system? You look at the same slopes and different y-intercepts. Okay, so I'm not asking you to graph example 3 or example 4. Okay, you'll do that in your assignment, but we won't do that today. Okay, so parallel lines, how many solutions are there? There's none. Okay, because there's no point of intersection. All right, now go ahead and try number 4. Okay, so hopefully when you solve those equations for y, putting them in slope-intercept form, you got y equals 3x minus 8 for both of those equations. So if you notice that both of those equations have the same slope and they also have the same y-intercept, you're going to plot -8 and then you're going to go up 3 and over 1. So you've got one line graphed on top of the other line, okay? That means that they're the same line. Because they share every single point between them on the xy axis, there's an infinite number of solutions. So we say infinitely many, okay? So same lines, infinitely many is the solution. All right? So that's all I've got for the notes. Make sure that your 3 pages get stagger stacked in your notebook under the first section for systems of equations, okay? Bring your questions to class tomorrow and we will dig into this a little deeper.